Welcome to the ChemDraw video tutorial. ChemDraw is a chemistry software that is used to draw chemical structures in a professional manner.
It can also provide users with very important information such as IUPAC names, molecular weights, and NMR predictions.
In this video, we will go through the installation process, the general features and shortcuts, and how ChemDraw can better your chemistry learning.
This tutorial will only go through the basics, so feel free to explore the software for more features.
First, start by visiting the library's Chemistry at UTSC website, which is found by going to uoft.me/UTSC Chemistry Resources. This website contains useful information about the installation of chemistry programs, as well as the location of campus computers equipped with these softwares. The ChemDraw software is available free to all registered students, faculty, and staff at or affiliated with the University of Toronto. You do not need to be on campus to download this software. On this website, under the subheading Tools for Drawing and Searching Chemical Structures, there will be a link to ChemDraw. Clicking this link will redirect you to input your UTOR ID and password. After you log in, a page of instructions will appear. Make sure you read over all the instructions first before you proceed.
Let's walk through the download steps. Please note that any reference to CambridgeSoft will now be PerkinElmer Informatics. Click the link in Step 1. You will be redirected to a My Access login page. Then click the link to log in with your UTOR ID. This will redirect you to the PerkinElmer Informatics webpage. If you have previously created an account, simply log in. If you do not have an account, click the Register button to create a PerkinElmer Informatics account. Complete the form using your email address that ends in mail.utoronto.ca. Click the Register button and click the Continue to your previous request button. After you have logged in with your PerkinElmer Informatics account and password, you will see a services box on the right side of the page containing links to My Site Subscription, My Downloads, My Database Subscriptions, Register My Software, and Request Information. Click on My Site Subscription, then select the Download Site Subscription Software link to download either the Mac version or the Windows version of the program.
After you have successfully downloaded and installed the software, the final step is to activate the software. When you start the download process, you should receive a serial number by email within a few minutes. If you do not receive it shortly, please check your spam filter. You can also retrieve your serial number at any time using the My Downloads link in the services box of your PerkinElmer account. Please note that you will have different serial numbers for Mac and Windows, and that the Mac installation will also require a registration code. Please make sure you use the correct numbers based on the operating system of your computer. To activate the software, open the program and complete the installation process by filling in the remaining bits of information and press the Next button. Keep the default location for the installation. Press the Finish button to complete the process. The license will allow you to install the software on a maximum of 3 computers. If you try to install it more than 3 times, you will be locked out of your account and will have to contact the PerkinElmer support to have your account re-enabled. Note, when you need to download the software onto a second computer, you log into your account and download the software again and just use the same serial numbers. One final note. Regardless of when you install the software, your license will expire at the end of November. You will receive instructions from the library to renew each year sometime before this date. If you graduated during the year, you will not be eligible to renew your license unless you are continuing at U of T as a graduate student or postdoc. After the successful installation of the software, you are ready to start using ChemDraw. This section will discuss and familiarize yourself with the common features of ChemDraw and where you can find certain capabilities or functions.
To open up the program, it is usually found under a file folder named ChemBioOffice. Downloading the software would also download other software that you can use. The program we want to use is ChemDraw Ultra. Ideally, when opening up the program, it will already open up a new untitled document on which you can draw your chemical structures. If not, then press Ctrl-N or go under File and click on New Document. This will be a blank document. However, if you would like to have rulers or crosshairs, also known as markings, those can be activated under the View tab on top and then click Show Ruler or Crosshairs.
There are also a number of different toolbars that can be made visible on your screen in order to help you when using the program. We recommend having at least these specific toolbars as their functions will be commonly used. Typically, they will already be on your screen. However, if these boxes are not there, make sure the following are checked off under the View tab on top: Show Main Toolbar, Show General Toolbar, and Show Style Toolbar.
Your main toolbar will be most commonly used as it provides users with all of the tools to start drawing chemical structures. You have icons such as single bonds, double bonds, brackets, benzene structures, and more. Simply click on the desired icon, then a single click on your document will draw the desired structures. With all the different icons, it will be difficult to remember all of them. Therefore, we strongly suggest and encourage users to move their mouse over the icon in order to help determine what the icons mean. Do not forget this capability and use it as often as you need to, because there will be many different icons in ChemDraw that may seem obscure to you.
If the icon has a little black arrow down, this means that there are more functions hidden underneath this one. Click and hold on this icon to reveal the other icons present. For example, there are different arrows with different radii. There are also different templates, ranging from DNA and amino acids. And users can also draw laboratory apparatuses. Remember, you must keep holding the clicker on your mouse when navigating these extra features, because once you let go, the program will take the last place your cursor was on as the function you wish to use. The lasso or marquee function is an excellent tool to select specific structures. Selecting chemical structures will allow you to resize these structures if you'd like, and also change its color or font using the toolbar on top.
Saving your work is extremely important. ChemDraw is able to convert your file to other forms such as GIF or PNG images. However, we recommend that you also have a ChemDraw file or .cdx file of your work. This version will allow you to go back into ChemDraw and make any changes to your structures if you need to.
To start drawing chemical structures, users can select on the desired icons and use it to draw the structure on the document. For double bonds and triple bonds, you may use the icons in the toolbars, or you can draw a single bond, Then click in the middle to increase the bond. Using the erase icon, we'll delete the chemical structure on a per bond basis. If you wish to remove whole molecules, it is best that you select it all using the lasso or marquee icon and then delete. When connecting bonds together, make sure your cursor has a blue box underneath it so that ChemDraw knows that whatever bond you are drawing is meant to connect at that point. You can also connect rings together very easily. First, click on the desired ring icon. Then, click and hold on the first connecting point while rotating the structure until it connects to the end point. ChemDraw also assumes that all the connecting points are carbon atoms. However, we can easily change it by clicking the text icon noted with the capital letter A. Then, clicking on the desired connecting point and type in the substituted atom. Sometimes it is also possible to not use the text icon, but simply placing your cursor over the point and then inputting a letter. This could still have some dangers. Sometimes, it does not always insert the intended element. For example, if you want nitrogen, noted with the letter N, simply typing in N without the text icon will give you sodium, which is Na. ChemDraw will also be able to detect simple mistakes in your structures. Typically, if the atom is missing a charge because it has too many bonds or too little bonds, a red box will appear around the atom. This is a great reminder for students to be careful of their charges and to always include them.
With text, ChemDraw can change the font, size, bolding, color, and much more using the top toolbar. You can even change the color and font of chemical structures as well. Make sure you select your compound and then change it to different colors if you would like. Sometimes, chemical reactions and especially reaction mechanisms can be very lengthy, and one page of document is just not enough. In this case, resizing the molecules could be a great solution to the problem. To resize the molecules, it is best to do it all at the same time so that you can appropriately size the molecules to be a perfect size. Start by selecting all of the molecules that you would wish to resize. Then place the cursor over one of the corners until you see the resizing arrow and drag the cursor in or out, depending on whether you would like to make it bigger or smaller. Once you let go, there will be a pop-up asking users if you would like to resize all of the drawings and text on the document to the same size. This will be up to your preference. Saying no will keep text and other future drawings you may draw to the original default size set by ChemDraw. Saying yes will appropriately scale all text and future drawings to the size you have indicated. Notice how specific ChemDraw will allow you to become. There are hashed and wedge bonds, chair conformations and different ring structures, and also double-headed and single-headed arrows with different radii too. In addition, the template icon will allow you to draw all sorts of complex structures such as amino acids and sugars.
One of the most useful functions in ChemDraw is the ability for users to input a chemical structure and get the software to output a full chemical analysis with its name, molecular weight, molecular formula, and much more. This is done by drawing the structure of interest, selecting it, and then right-clicking on the structure. Under Analysis, select the All option. A text box should appear underneath the structure with all the desired information. While this is a great capability, Users must keep in mind that it will generally output the IUPAC name of the structure, not common names. It is possible that sometimes structures can get so complicated that generating the IUPAC name is difficult. So do not be too surprised if ChemDraw tells you they cannot generate a name for the structure.
If users simply want the name of the structure, that is possible as well by again selecting the structure, right-click, and under Analysis, click on Name. Another method to achieve the same task is to select on the structure, and under the Structure tab on top, click on Convert Structure to Name. We can also go in the reverse direction and input a name of a chemical and ask ChemDraw to output the chemical structure. This function works best with IUPAC names. However, it will be able to accept some common names, especially if they are extremely well known. You would use the text icon, type in the name of the chemical, select it, and then on top, under the Structure tab, click Convert Name to Structure.
In chemistry, especially organic chemistry, chemical reactions and mechanisms are extremely important. This section will outline how to draw a chemical reaction from start to finish. For this demonstration, we will be drawing a Claisen condensation reaction with ethyl propanoate.
Chemical reactions depict a complete outline from reactants to products with necessary solvents and reagents. The key things to remember are reactants on the left, products on the right. Use the appropriate arrow, whether that is a single-headed arrow or a double-headed arrow, for reactions that can go in both the forward and reverse directions. Balance the chemical reaction. We cannot stress the importance of this and do not forget to do this. Note all reagents or catalysts above the arrow, while solvents and reaction conditions are stated below the arrow. And finally, keep it consistent. Consistency is what makes the reaction professional and easy on the eyes. The best chemical reactions have the structures in the same size, and they have chemical names with their corresponding structures.
So to get things started, we first will start by drawing our reactants. Using the toolbar on the side, we will click on the appropriate icons to do so. If you are having difficulties with creating these structures, refer to the Drawing Simple Structures section for all of these tips. Make sure you remember to add a plus sign on both reactant and product side when you have more than one reactant or product. Make sure you have the reaction balanced, and now would be a good time to include the coefficients using the text function. Next, we would draw an arrow to show the reaction progression to the products, and then draw in our products. For this reaction, there are key reagents and reaction conditions to be noted in our reaction scheme. Again, remember that reagents are on the top, while solvent and reaction conditions are noted on the bottom. At this point, you can select each individual compound and use the Convert Structure to Name function under the Structure tab to generate the names of all the reactant and products.
As you can see, while we constructed our chemical reaction, we do not worry too much about making sure everything is evenly spaced out. Do not waste your time doing this because ChemDraw can space reactions for you. Once you have completed, highlight the whole reaction. Then under the Structure tab on top, click on Clean Up Reaction. This will evenly space out everything so that it looks professional and appealing to the eye.
Unlike chemical reactions, reaction mechanisms are a visual outline of the movement of electrons within the compounds to show how these compounds interact with one another to form the end products. Reaction mechanisms can be lengthy, and so it is important again for users to be as consistent as possible so that their mechanism will be clear and take advantage of your resizing function. For chemical mechanisms, the most important part that users should be most mindful of are the arrows. Under the arrow icon, you can see that there are various options of curved arrows to show movement of electrons. There are arrows of different radii, and users can select the most appropriate one depending on how far apart the starting and end point of your electron pair movement. You can also manually change the radius of your arrows by dragging at the location of the white boxes. There are also single-headed arrows to show the movement of a single electron, like in radical reactions. For this section, we will demonstrate how to construct a reaction mechanism with a reaction between propanoic anhydride and ethanol. This will be our end product.
For many undergraduate students, mechanisms are challenging and a concept that you all are still grasping. Therefore, we recommend that you draw the mechanism out yourself on paper before you do it on ChemDraw. That way, any mistakes or confusion can be resolved. In addition, this is a really good technique because then users will know how lengthy the mechanism will be and can arrange their mechanism accordingly. Once you have it on paper, it is a matter of transferring that onto the software. Start by drawing the reactants. Remember, for mechanisms, it is important to include your lone pairs of electrons. The icon may be hidden under the charges icon. Make sure you have your cursor fully over the atom until you see the blue box around it. If you just click on the atom, it will place the lone pair randomly around the atom. If you would like to place the lone pair at a specific location, click and hold until you have the electrons in the right place. Include your arrows where appropriate, and it is key that the users are careful with the starting and ending point of the electron movement. Try your best to be as accurate as possible. You may need to move the compounds around so that they are at the right position with the arrows. As you may have noticed, these arrows are not very flexible, which is why moving compounds may be easier. Unfortunately, with mechanisms, the cleanup reaction function does not work, so users must try to make the compounds as consistent as possible.
One of the functions in the ChemDraw software is the TLC templates that students can use in order to present their TLC data in a professional manner. On the side toolbar, the Advanced Tools icon has a TLC icon underneath it. This can be accessed by holding down the icon and dragging your cursor onto the other icon that looks like a TLC plate. Next, you would drag the cursor on your blank document in the same way you would make a regular box. As you can see, if you drag it down, it will make the plate longer, which ultimately is not as important because TLC uses retention factor values, known as RF values. This will be more so for your preference. You can also drag the plate to the right in order to increase the amount of lanes. Once you let go, the TLC plate will be set. Changing the dimensions of the plate now will not increase the number of lanes, but it will just increase the width of the plate. If you decide at a later time that you need another lane, place your cursor at the starting line until you see a blue box. Right-click and press Add Lane. Now to depict the location of the spots on the TLC plate, place your cursor over one of the dots until you see a hand. Then, click and drag the dot until the desired RF value is noted at the side. You can also achieve the same goal by right-clicking over the dot and selecting Set RF, and then inputting the value in the pop-up window. It is also good practice to visually display the RF value, and so right-click on the dot and click Show RF.
Sometimes in one lane, there are multiple spots seen because there are multiple compounds in the sample. To add another dot to the same lane, place your cursor over the desired lane, right-click, and press Add Dot. Then repeat the previous steps to adjust its position to the appropriate RF value. As you can see now with this TLC plate, the spots are a series of the most perfect spots that you will rarely achieve in lab. Most of the time, TLC plates will have streaks and dots with rings around it. And as scientists, it is in our best interest to represent the TLC plate obtained in lab to the best of our ability. If you notice that there is a light ring around the dot, you can depict this by right-clicking on the dot and selecting Solid Doubled. There are also other representations that you can explore and use. To show a streak spot, place your cursor over the desired spot, then press and hold the Shift key. By doing this, your cursor should now have turned into resizing arrows. Use the down portion of the resizing arrow to drag the spot down to the desired length. You can also use similar steps to resize the spot's width. This can be a slightly difficult task because the dot can be small, so magnify the area if needed. It is important to mention that representing the streak does not change the RF value. Remember, you will still need to identify the samples for each lane.
An additional and quite useful function of ChemDraw is its ability to generate both proton and carbon-13 NMR predictions of chemical compounds. First, the chemical structure must be drawn on a blank document, and then select the compound. Next, click the Structure tab on the top bar and select Predict 1H NMR shifts for proton NMR, or Predict 13C NMR shifts for carbon-13 NMR. A new document will appear as the NMR report. It will show the intended structure with corresponding chemical shifts, or ppm values, at their predicted atom location. There is also an accompanying NMR spectra and a report about the predicted coupling constants for the signals for a proton NMR. Remember, we will not see these coupling constants for carbon-13 NMR because it usually does not have split signals. These ppm values on the structure will appear in one of three colors: blue, pink, or red, which indicate the reliability and strength of the predicted signal. Blue signals are very reliable and is considered a good signal. This means that there is a high chance that other samples containing the compound will display that NMR signal in a similar ppm value. However, red values are unreliable, and there is a good chance that the signal will not appear at the predicted ppm value on sample spectra. As we know from NMR theory, NMR signals, specifically the chemical shifts, can vary due to a number of outside factors of the sample conditions, such as temperature and solvent used. Most chemistry software that predict NMR spectra follow a general and basic sample conditions, and ChemDraw is no exception.
Therefore, often we find that these NMR predictions may not be representative of your sample that you synthesize because your reaction may be carried out with different conditions or solvent systems. It is imperative that students still consult published literature from Reaxys or SciFinder that gives NMR data obtained from similar reactions. Citing existing literature is more credible for lab reports than citing these NMR predictions from ChemDraw. Having said that, generating these NMR predictions is a very good starting point in deciphering the identity of your peaks. Students should generate NMR predictions of their compounds as a part of their pre-lab procedures.
Thank you for watching this tutorial video. We hope that it has helped you in understanding the ChemDraw software.
Even though this may all seem very easy, do not underestimate the time it takes to carry out these tasks, especially if it's your first time navigating the software.
If you have any problems, please don't hesitate to consult other resources. Thank you and good luck.